Okay, let's pick up where we left off. Modeling real world problems with linear functions. All right. Example 8, using a linear function to determine the number of songs in a music collection. Let me do this so I know. Marcus currently has 200 songs in his music collection. Every month, he adds 15 new songs. Write a formula for the number of songs in is his collection as a function of time. So n as a function of time. Now remember, if we're doing word problems, I always suggest you think of it more in this way as opposed to mx plus b, because you can start off with what do they have already? What's the initial value? And in this case, the initial value, b, is 200 because he has 200 songs before he even does anything else. But from there, is he adding or is he subtracting from that initial value? So he's adding, and they even tell us he's adding. He's adding what? He's adding 15 new songs per month because they're telling us every month, and we're using t as time. Okay, and t is representing the number of months. All right, so we have our function. The question is, how many songs will he own at the end of the year? Well, you can't answer this if you just plug in 1. You have to know what the t is representing, and t is just the number of months. How many months are in a year? 12. So he's going to go 12 months. How many songs will he have? So that's 200 plus 180 is 380 songs. So Marcus, let's answer the question. Marcus will have 380 songs in a year. Boom. Next. All right, working as an insurance salesperson, Ilya earns a base salary plus a commission on each new policy. Therefore, Ilya's weekly income, I, depends on the number of new policies he sells during the week. Last week, he sold 3 new policies and earned $760 for the week. And the week before, he sold 5 new policies and earned $920. Find an equation for I of n and interpret the meaning of the components. So the I of n, I think at this point you could probably do, but the interpret the meaning is what I really want you to get a lot out of at the end of this section, or at the end of this piece. So you can see here that there's 2 different points happening. If he sells 3 policies, he gets 760. If he sells 5 policies, he gets 920. So how much does he get per policy? Let's find out. So rate of change, m equals y sub 2, let's label x1, y1, x2, y2. Y sub 2 is 920 minus 760, which is y sub 1. X sub 2 is 5 minus x sub 1 is 3. All right, 920, 760. I think that's 520. Let me just verify. 920 minus 760. That's not right. Is that right? Oh, yeah, it is 160. 160 over 2. So it's $80 policy. Okay. 160 over 2, which is $80. So he gets $80 per policy sold. All right. But he gets a base salary. So we have to go back and find out, well, what's his base salary? We know this is how much he gets per policy. So this is his 80 in. All right. So we're going to have I of n is equal to his base salary, which is the initial value, plus he gets another $80 per policy sold. So we need to know that the N is the policies sold. All right, let's find B. I can choose either one of these points and plug them in for our Y and our function and our N. So I'm going to choose 920 is equal to B plus 80 times 5. Okay, so 920, here it is, plus 400, subtracting 400 from both sides, is 520. All right, so we now know the rate of change. We now know the initial base salary he gets. Let's create our function. I of n is equal to 520 initially, and then $80 per new policy. All right, and that's what the interpretation means. Read this as the language it is. So what does I of n represent? Well, the meaning of the, okay, so where's it at? I have end. It's his weekly income. So Ilya's weekly income. I'm using their words. And then he has a base salary, of, don't forget, correct units here, $520. And then sells during the week and earns $80 for each new policy sold. That's the interpretation. Okay, it's just explaining what's happening here in this function. Example 10. Using the tabular form to write an equation for a linear function. So we're going to use this table. It's a linear function, so we could choose any of the points in this. Just understanding that if you're thinking in terms of x and y values, all of your x values are right here, and all of your y values are here. So this is a point, 0, 1,000. Here's another point, and here's the last one they're presenting us. Now, we're going to write, what is this? P of W is the function they're using. We know the initial value, it's 1,000, because when x is 0, that is your y-intercept. All right, so plus 1,000, we've already got our b. Now we just need to know what the coefficient, our slope is, our rate of change for this. So that's just m is equal to, and we've got points, what? We just use 6 in this one, so y sub 2, x sub 2, and I'll use this one because it's easy. Y sub 1 and x sub 1. So y sub 2 is 1240 minus $1,000 over 6 minus 0. All right, so that's 240 divided by 6, which is 40. There you go. That's it. That's all they wanted us to do. Cool beans. All right, next one, graphing linear functions, graphing by plotting points. All right, I'm excited because I get to show you this way as well as the way that I find it so much faster to do. But plotting points, I want to make sure you understand it's easy to choose if you don't have any fractions. If you're going to plot points, and I would expect to see this on your exam as well if I ask you to plot points. I want to see a table. I want to see you create a table so I can make sure that you're not just going off of, I mean, you still may be going off of Desmos, but anyways, if it's not a fraction, I would typically choose for my x values -1, 0, and 1. I never go with just 2 points because a third point's there to make sure that your line's not wrong. And 3 points will pretty much guarantee that. So, but given a fraction in my function, there's an easier way to do this. I do not choose -1, 0, 1 because it's a beast. I choose instead based on the denominator. So we're given 3 as the denominator. So I'm going to choose, 3, 0, and -3. Let me pause. What's going on with them? All right, dogs. So if I do this, then I can just plug in 3 for x and they'll reduce. So I'm going to show you what this looks like. So f of 3 is just -2 over 3 times 3 plus 5. Look at that. Isn't that gorgeous? So that's just -2 plus 5, which is 3. Okay. F of 0, even sweeter, -2/3 times 0 plus 5 is just 0 plus 5, which is 5. And then the last one, f of -3, is -2/3 times -3 plus 5. 3's are gone, but when you reduce the 3 here, don't forget there's still that negative, so I like to put a -1 to represent. -2 times -1 is 2, plus 5 is 7. All right, plotting these points. The x values you're going to go right and left for, so starting off with 3, 1, 2, 3 to the right since it's positive, and then we're going to go up or down for y. In this case, we're going up since y is positive, we're going up 3. 1, 2, 3, placing my point, and then I can label that 3, 3. The next one is 0, 5. 1, 2, 3, 4, 5. It's 0, 5 is just on the y-axis because that's our y-intercept. And then the last one is -3 from the point of origin to the left 3. 1, 2, 3, and then up 7. Well, this is 5. 2, 3, 6, 7. All right. Does that feel right? It's gonna not feel right when I draw it, I can tell you that. All right, let me plot these other points real quick. 0, 5 and -3, 7. Don't forget, when you graph something, name your baby. So f of x, you're just rewriting what the function is, equals -2/3 plus x plus 5. All right. I want to do one more, and then I'm going to make another video for the transformations of these functions. So graphical interpretation. If you understand that m, your slope, means rise over run, okay? And if you understand that your b is your y-intercept, then graphing this function is so much easier without plotting points, as far as using the tabular version, creating a table with -3, 3, and 0. Instead, I start off with, what are these representing? Well, this is my y-intercept, and it's positive. So from the origin, I'm going to go up, since it's positive, 5. So 1, 2, 3, 4, 5, place my point. There's my first point of my line. I'm only going to get 2 points from this, but I can keep going and actually get an infinite number if I want to keep using the slope to find it. From the point I just created, okay, I'm going to follow the slope. And because I've got a negative, the negative always goes to the numerator. The denominator is always positive, and you will always run to the right, because this is rise over run. So because this is a -2, we're going to rise, but it's actually going to go down, -2 from the y-intercept. So 1, 2, and then we're going to run 3, and remember, we're running to the right. So 1, 2, 3, placing my point, drawing my line. Okay, and then again, name your baby. Okay, I like those. Those are fun. And that's it. I'm going to come back to transformations for the next video.